Alright, so now we're moving past direct variation into inverse variation. And if you recall, when we worked with direct variation, if we were double an x term, then we would double a y term. If we were to divide a y term by 3, then we're going to divide an x term by 3. And an inverse is going to do the inverse operation of both. So if I'm multiplying, that means I divide. And if I divide, that means I multiply. So first, the equation of inverse variation. Y equals some constant k divided by x. And the way you read this, y varies inversely as x, or y is inversely proportional to x. We're not going to work on the graph of inverse variation yet, but we will work on some word problems and compare them to the word problems with direct variation. So here's an example. Y varies inversely as x. So there's my cue to write the inverse variation formula. If the value of y is 8 when x equals 2, then what's the value of x when y equals 16? And we're going to handle this just like we did with inverse variation. We're going to take the first scenario, y is 8 and x is 2. And then we're going to solve for k. So y is 8 when x is 2. And now we can solve for k. This is 8 over 1, so let's cross multiply. 8 times 2 is 16. K times 1 is k. So now we have a value of k of 16. So we don't have to write an ambiguous formula. We can write an explicit formula. Y equals 16 over x. And now we could look for our second condition. What is the value of x when y is 16? So 16 equals 16 over x. This is 16 over 1, so let's cross multiply. 16 times x is 16x, and 1 times 16 is 16. Finally, divide by 16, and you get x equals 1. Let's look at this another way. They gave us an x value and a y value. We'll be looking for either a second x value or a second y value. So what is the value of, if the value of y is 8, y1 is 8, when x is 2, x1 is 2, what is the value of x, looking for x2, when y is 16? So now we are given two y values. So what happened? We went from 8 to 16, which means we multiplied by 2. So what do we do with our x term? We divide by 2. We work with the inverse operation. We multiplied the inverse of multiplication, division. So instead of multiplying my x terms, I multiplied my y terms. So I work with the inverse operation on my x terms. Here's another example. Y varies inversely as x. Here's my cue. Y equals k over x. If the value of y is 3 when x is 2, what is the value of y when x is 8? So let's use our first condition. Y is 3 and x is 2. Let's solve for k. Cross multiply. So we get k equals 6. So our inverse variation formula is y equals 6 over x. All I did, plug that in for k. So now let's work with our second condition. What is the value of y? That's what I'm looking for when x is 8. Well, that's pretty easy. All I have to do is kind of clean that up. Divide them both by 2. Oh, that's not 6 divided by 2. So y equals 3 over 4. Let's look at this another way. We're given an x1 and a y1. We'll be looking for either an x2 or a y2. If the value of y is 3, y1 is 3, when x is 2, x1 is 2, what is the value of y? That's what we're looking for when x is 8. So, we're given two x terms. in order to get from 2 to 8, I multiplied by 4. Since we're varying inversely, I work with the inverse operation of multiplication. I multiplied by 4, which means I divide by 4.